Well, hello again and welcome to a new video. And in this video, we are going to talk about references, functions passed by references, and overloading functions. Let's talk about references first. What is a reference? After we know what's a reference, we will know why is it important in functions. So let me show you an example here. So if I declared a variable and I call it x, and I assign 5 to x, and x is an integer, what's going to happen basically, if you imagine that this here is the RAM, inside your memory system, the operating system will reserve a spot, and that spot's going to be called x, and 5 is going to be stored in that spot. Now, if I create another variable, integer y, and y equal 5, the same thing will happen. Another variable, another space, will be created inside the memory, and it's going to be identified as y, and the value 5 is going to be stored there as well. Now, here's an option that you have, and this option basically is creating a reference. Now, what does that mean? Let's imagine that I'm going to create a reference, integer, you put the percent here, and you put z, and you say equal x. And this is the AND operator. Simple, but I don't know how to write it down correctly. I'll show you that when you get to the Visual Studio. So this statement here basically means create a new variable, which is z, and z is going to be used as a reference. And this here is how we decide if z is going to be used as a reference. And then we're going to assign x to it. So what exactly I'm doing here, when you create a variable, this method, what you're doing basically, you are basically having the same spot or same space inside the memory to be referenced by x and also to be referenced by z. So I have now two identifiers. One of them is called x and the other one called z, and both of them are referencing the same spot and the same area inside the memory. So again, what does that mean? Well, basically means if I take z, for example, and I change it to 10, that implies that x equal 10 now. And that's basically what we mean by referencing. So let's go ahead and have an example about that here. So if I have an integer x equal 5, and if I have an integer, let's call it z, and let's set that to x. Now let me just show you what's going to happen. If I go show me x now, and line, and now if I come here and say z equal, well, I used 5 before, so let's keep it 5. And then I'm going to change z to equal 10. And then I'm going to show x again. And let me run it. And here we go. You can see the first time x was printed as 5, and the second time x was printed as 10. Now, you have the right to ask this question. Why do you have to go through all this to change the value of x? Why don't you just go ahead and change value of x? Well, there's a reason for that. We're going to be explaining it in the next part of this video. But for now, the bottom line, what I'm trying to say here is, you have a feature or a tool or a method that would allow you to process a variable and process a data without actually having access to that data directly. And that's the whole point here. The point here that I want to change x, but I don't want to use x because sometimes I do not have access to x because of the scope of the variable. So how do I fix that problem? Well, reference is the solution. And again, you can see here the syntax is very, very simple. Number one, same data type for both of them. And you just have to put the and percent here operation, simple here, and then assigned x to that z. And now I can play with z as much as I want, and the value of x will still have the same effect. Now, with that being said, let's talk about functions that pass by reference. Okay, now what I'm going to do, I'm going to show you an example in real life. Let's imagine I have well, before I get to that, let's just have a very simple function, then I'll show you that example. I have a function, let's say, call it return void. I will go to test. test function. And in this test function, I am going to pass two variables, integer n1, integer n2. So I'm passing two integers, n1 and n2. Here, let's imagine I want to multiply n1 to equal n1 multiplied by 10, and n2 to equal n2 multiplied by 10. So the job here is for this function, basically, it receives two parameters, and it updates each parameter by multiplying it by 10. So basically, if I pass 5 here, n1 is going to be updated to be 50. If I pass 7 here, n2 is going to be updated to be 70. So let's go ahead and have a scenario here. Let's say, imagine I have an integer, I will call it num1, and I'll pass 5 here, and then num2, and I'll pass 7 here. And let's go ahead and do a before and after. Cout before, and I'll show you n1 num1 space num2 end line. After that, I'm going to call the function, which is test fun, and I'm going to pass num1 and then num2. And you know what? Let me just make it a little bit more confusing. I'm going to change this one to be num1 and this to be num2. Okay, and let's go and do before and after. Okay, so what's going on here? Now we covered this part. Let's talk about this part here. I have two variables, num1 and num2. Remember, num1 and num2 are local variables for the main function. So I do have them printed on the screen here. Right after that, I call this function. Now remember, num1 is going to be passed to num1 here. Oh, I had to change this to as well. And num2 is going to be passed here. Num2 is going to be passed to num2. Now, let's just put some rules here. Rule number 1, just because they share the same name, that doesn't mean they are the same variable. Let's just put it that way. So num1, which is inside the main function, will be passed, the value of num1 will be passed to num1, which is a member or a parameter in test fun. Same thing for num2. Now, we said that before, when you pass arguments to a parameters in a function, the default method that the C++ is going to use is pass by value or pass a copy. And pass a copy basically means if you have a document and you want to give that document to someone else to use it, passing it by default will be like you're having a copy of that document and you pass it to that colleague or that function here. You don't give them the original copy. So basically, if they decided to burn their copy, your original copy will not get affected. And this explains what's going to happen here. So before, I'm going to have 5 and 7. And then after, well, basically what I did, I passed the 5 here and I passed the 7 here. 5 was updated here, 7 was updated here. But again, this is for those local variables. The original one will not get affected by that. And let's just run it so you'll understand what's going on here. And you can see here 5, 7, 5, 7. Okay, so how is referencing helping here? Well, here's the idea. If I come here and put the ampersand operator like that, what's going to happen here? You're not passing those by copy anymore, because what do I have here? I have a reference declaration. So just like here, this z is not a variable, independent variable inside the memory. No, the z here is going to referencing the same variable that x is referencing. So same thing here, num1 here and num1 here basically are going to be referencing the same spot inside the memory, so the change will be applied. Just to give it a little bit more, just let's put it back to be n1 and n2 so you'll understand the concept. And now let's run it. And look what just happened. So here we go. This is what we mean by passing by reference. Now you may ask the question, what is the point of all of that? Well, and here's something you have to put in your mind. Sometimes in functions, when you pass values, arguments to a functions, you want that function to process the data, change them, modify them, but you don't want the original one to get affected by that. And if that's the case, you pass by a value. Now, what if whatever modification and change is going to be applied to that function, you need it to be back in your main function when it's done? That's where you pass by reference. Now, let's update this example to something meaningful. I'm going to create a function called swap. And I'm going to come here and type swap. Swap basically means this function basically will change the values of num1 and num2. So originally, num1 equals 5 and num2 equals 7. Now what I want this function to swap them. So num2 is going to equal 5 and num1 is going to equal 7. The idea is very simple. You create an integer. I will call it temp. And this is what I'm going to do. I'm going to show you that. Let's just do that here. Control N, do not save. And here we go. So I do have N1 here, N2 here, and temp here. What I'm going to do, I'm going to come here and say temp equal N1, for example. So what I'm doing here, for example, if N1 was 5 and N2 is 7, now after this operation, temp is going to equal 5. So I have 5 stored safely inside temp. Now right after that, what I do, I come here and say N2 equal N1. Oh, wait a minute. No. N1 equal N2. So what did I did here? I took the value of N2, which is 7, and I stored it in N1. So at the end of this operation, N1 equal 7. So I have N1 to equal 7, but still N2 is supposed to equal 5. Well, where's 5? 5 is stored inside temp. So all I have to do is to come here and say, N2 equal temp. And that's where you get the 5 to be stored inside N1. And that's basically how the swap works. So let's go back here. I have temp here. So basically temp equal N1, and then N1 equal N2, and then N2 equal temp. And this is basically how it's going to be done. Now, what I'm going to do, I'm going to take the reference operation just to show you how cool this feature is. And okay, let's run it. You'll notice that passing it normally would not change anything. But if I just put the ampersand here and the ampersand here, that will give me the effect that I'm looking for. And here we go, 5775. Now, again, that's basically how simple it is. This is basically what we mean by passing by reference. The idea is very simple, is to use this percent here to pass value. Now, again, it's going to be your decision. It depends on the program or the problem you're trying to solve. Sometimes you pass by reference. Sometimes you don't pass by reference. It depends on what you're trying to do. You will see, maybe not in this class, but in the advanced classes later, you will see that, no, it's going to be a really big deal to know how exactly to pass your references. So this is basically what we mean by pass by reference. I just need to warn you here that we also have another option, which basically passing the addresses and using pointers, but that will be a whole video by itself. We're going to talk about it later, and we're going to see the differences between references and pointers later. So this will be the part where we talk about function passed by references, and now we're going to talk about overloading. Overloading as a concept is pretty important, and you are going to be using it a lot. So let me just create some space for this concept here. Now we're going to be talking about method overloading or functions overloading. Before I define what is function overloading, let's just have a scenario here and see the type of problems that we might end up facing when we create functions. I'm going to create a function that will add, let's say, two numbers together. Or you know what? Let's use the swap function here as an example. That would make perfect sense. So what I'm going to do, I'm going to copy this. I'm going to put it here. And I'm going to change it. Instead of swap, I'll just call it swap with an uppercase S. I'm going to change that in a sec. And let's say here we do have two variables. Let's call this one 3 and 4. And let's call that function swap with an uppercase S. Uppercase S, and we'll pass N3 and N4. Now, as you can see here, I didn't do any change here, but let's do the before and after, just like we did here. So before, let's put 3 here and put 4 here. Let's change the values. I'll put here 12 and I'll put here 54. And I'll copy this and put it under it and say after. After. Oops, not after here, sorry. This is where I type after. Okay, now this function again will just act as the one before it. And here we go, before and after. Okay, now there's nothing different here, but the question is, what if those are not integers anymore? For example, if I have doubles, and let's just put 12 point something like that, and something like that. And look what just happened here. Immediately we get an error. What is that telling me? Telling me that you cannot use this function anymore because we have an integer reference here and you're trying to pass a double. It will not accept it. Now, if I take this one here away, it's going to work, but again, I'm passing a double to an integer. Whatever change I'm going to apply here is going to be treated as an integer, not a double, and I'm not going to be able to get my results back. So here we go. We do have a problem. So how do we fix this problem? Well, I will show you the not smart way to fix this problem. Well, I'm going to come here. I'm going to change this function to call swap integer. Okay, and I'll just come here and change this. Let me just go back to the original case. So I'll just go ahead and put swap here, and I'll put integer. And of course, oh, I just typed int, sorry for that. I'm still gonna have issues here, and let's put this back into an integer case, integer, and I'll take those away and this away. So as you can see here, this function here perfectly will work fine with integers, but if I want to create another function to deal with doubles, well, again, this is not the smart way to do it, but here's what I can do. I can copy this, put it here, and change this one, instead of swap integer, to swap double. And instead of integers, we'll change those to be doubles. Double, double, and double. Now I have two functions. One of them is called swap integer, swap double. And let's copy this, put it here. This time I'm going to come in with double variables, and I'm going to call this one, for example, 5, and I'll put number. This will be 6. I'll put something like that. And now before and after, this will be 5, this will be 6, this will be 5, this will be 6. And the same thing here. I'm just going to come here and type 5 and 6. And instead of pass swap double, copy that and put it here. And again, I just told you that this is not the smart way to do it, but again, it will work with no problems. And you can see here, this is before and this is after. Okay, now, what if, again, I want to perform the same operations using floats or using characters? Let's go with the characters. Well, again, all I have to do, copy this, and go down and change this to be character. And remember, that basically means you have to come here and say this to be character, this to be character, this to be character. And now, look what I'm going to do. I'm going to copy this, put it here. And before we do the before and after, I'll go character C1 equal A, C2 equal B, semicolon. And then this will be C1, and this will be C2. And this will be C1, and this will be C2. And remember, this will be swap character C1 and C2. Now remember, this will work as well. Let's just run it. And here we go. Well, oh, did I put 1 instead of A? Yeah, exactly. Here, 1A. Go back here again, run it, and here we go, before and after. Okay, now, so obviously, whatever I just did here, it's working with no problems. So why did I say this is not a smart way? Well, here's the thing, and let me just tell you that from now. In addition to those primitive data types, you will have a lot of other non-primitive data types. Like objects you're going to create, or objects, for example, swap strings, swap cars, swap houses. Now, the question is, imagine yourself creating a project, or you have a project you're working for a client, and then he wants you to create a program. As a part of that program, there will be a swapping operation. So instead of coming to that user, and again, remember, one of your jobs is basically to hide those details from the user, make the user be able to use your program as simple as it is. So instead of coming to the user and telling him, well, if you want to swap 2 variables, you have a function called swap. No, you give him 10 functions. We say, okay, if you want to use integers, you have to use a swap integers. If you want to use cars, you have to use swap cars. If you want to swap doubles, you have to use swap doubles. You know, you're going to be talking and talking, and you will lose his interest will be basically gone. He doesn't like it anymore because you're giving me a headache with all of this talk. So the question is there any way I can replace all these methods with one that will work no matter what is the scenario? The answer will be yes, and that is basically what we call templates. But here's something. Templates is a little bit more advanced, so we're not going to be talking about templates right now. We're going to be talking about it later in more advanced videos in the future. So, is there any other way I can fix this problem without the need to worry? Well, the idea here is yes, and very simple. And the solution here is what we call method overloading. Now, method overloading basically means, and this is extremely important to understand, what I'm going to do, I am going to take, well, you know what, let me comment this method at the top. And this is what I'm going to do. If I take all these added words that I have here, swap, character, swap, take them all out. What do I end up? I have a swap, I have a swap, I have a swap. Let's go back down and see. Well, yeah, I need to change this, of course. Swap, swap, and swap. And wait for it, and you'll see, oh, everything is gone. Okay, so what did I do here? You see here, I do have 3 methods. They all have the same name. Okay, so this is one of the definitions of method overloading, is basically to have multiple methods that share the exact same name. Whatever's going to be returned is not a big deal. You can have it to return anything. It can return different things. That's okay. But the most important part is they need to share the same exact name, but at the same time, they need to have different number of arguments or type of arguments. And this is very important to understand. So what is that? How's that important? Here's how it works. When I came here and say swap, the compiler will look at num3 and num4, and the compiler will figure out that, oh, num3 is an integer and num4 is an integer, and yet I do have 3 different swaps. So which one of them will match with my arguments here? And the compiler will say, oh, I got 2 integers here, so here it is. I got the match. So the compiler will know that this one should be called. Now, when I called this swap here, I have num5 and num6, and num5 is double, num6 is double. And if you go, the compiler will look, oh, I do have a double and a double. So here's my match, and this is what is going to be executed. And the same thing here for the characters, character, and I do have 2 characters, and that's basically how the compiler will be able to tell which one of them should be called. So method overloading basically means, or function overloading basically means, if you have multiple functions that share the exact same name, but have, look at this is very important to understand, have different type of arguments or different number of arguments or a combination of both of them. Like they're different in types and different in numbers. Like one function will have 2 and the other one will have 3. And even the data types are different. So this is basically what we mean by function overloading. And you will, again, this is not the only reason why we use function overloading. It's also related to, I need to drink some water. Okay, a lot better. So where was I talking? Yeah. We do have multiple functions. As I said, this is not the only reason why we have swap function, but again, later when you're going to get more advanced into object-oriented programming, you will see overloading constructors are used a lot, and there's a reason for that, and it's going to be explained later with a lot more details. But what's very important for us to understand that having multiple functions that share the same name, but they are different when it comes to the number of parameters or the type of our parameters or both of them together. So that's basically what function overloading function overloading is. Now, thing you don't want to do is to combine characters. For example, if I come here and say swap, and I'll just pass, for example, num3 and then num6. I'll put semicolon here. Why are you complaining here? Did I misspell it? No, here it is, swap. Let's put the mouse here. Yeah, I should. Exactly, that's what it says. There's no match, there's no case to match the arguments. Like num3 is an integer, I believe, and num6 is a double. So there is no function here with an integer and double altogether. And that's why you're getting this error. That's not acceptable. Now, this example that I'm using here will work if I'm passing variables, because after all, I have references to receive it. But I'm going to show you another example right now about method overloading where I don't have parameters, but you have to pay attention to what's going to happen there. And let's just make it simple this time. In this area, I'm going to create a function. I will say it will return an integer, and this integer called add, function called add, and I'm going to pass integer n1, integer n2, and this function simply return n1 plus n2. And put semicolon. I just put it this way, so I'm not going to use a lot of space. Now let's look at this add method, n1 and 2. If I come here and I'm going to say cout add, and I'm going to pass 6 and 9 and line, and I put semicolon. See, this will work perfectly fine. Let's just go ahead and show you the results of 6 and 9. It's supposed to be 15, and here it is, 15. Now the question is, let me close this. What if I pass 6.9 and 9 point, let's say 6? Just make it that simple. So the result's supposed to be 16.5, I believe. Let's run it. And I still have 15. So what just happened here? Well, again, you're passing a number with a decimal point to an integer. So what C++ will do basically will ignore whatever you have after the decimal point. Now remember, whatever I'm teaching you here, at a certain point you'll find yourself replacing it with a template, but there are other situations where no, you have no choices, you have to go with the overloading. But for now, since we are not at template, so if you choose to forget I mentioned template, go for that. Here's what I can do. I can come here and say double, and I'll call it add. Again, remember we're doing method overloading. Double n1, and then double n2. And just like we did before, return n1 plus n2. Now just let me tell you something. I can't stop saying this, but this is considered redundant at a certain point. Well, look at this, especially the body of the function. It's exactly the same. So that's where templates will be really, really helpful. So now that I have my function overloaded with doubles, you'll see that I will actually get the right results now. And here it is, 16.5. Why? Because the compiler was looking here, and the compiler found, oh, there is a decimal point here, and there is a decimal point here. So it's more likely to be treated as doubles, and this is what happened here. Now, this is something you don't want to do. Having one variable to be a double and the other one to be an integer, and this is where you get the compiler to be confused. What am I supposed to do here? Well, there's a solution for that, of course, if you want. And here's what I'm going to do. I'm going to copy this, put it here. But again, just imagine you didn't think about the solutions. You should always pay attention to the data types when you call a function. Change this to be an integer. Go away. No, he doesn't like it. I save it. Yep, it's a Visual Studio thing. Sometimes Visual Studio is so dumb it takes him a few minutes to realize what's going on. And here it is. Now it's working perfectly fine. Okay, what if I did this? Immediately, let's go ahead and do that. Copy this and put it down. And change this to be an integer. And change this to be a double. Come on, Visual Studio. And here we go. So as you can see here, method overloading is not a complicated topic, but you just have to pay attention to those small details. And method overloading, if I want to define it, is basically having functions that has the same exact name, but they are different when it comes to the type of the arguments and the number of the arguments. Now, in this example, for when I created those two variables, I just showed you that the order is also very important. And because the order is important, I had to create two additional functions to handle the situation here. This will be the end of this video, and I hope everything was clear. And I'll see you guys in the next video.